Thomas Witherspoon is the executive director of a remarkable nonprofit organization called Ears to Our World. Their website is etow.com, and they provide very low-cost radios, AM/FM shortwave receivers, to impoverished villages that have nothing. We're talking dirt poor villages with no electricity, no infrastructure of any kind whatsoever, so that the school in these villages can have some source of information about healthcare and other really vital information. So that's admirable in itself, but he has spearheaded a project to archive radio programming in a way that is kind of a mind-bending trip, and trying to figure out, and trip in more than one ways, trying to record like entire spectrum in context. So I'll let him explain how it works, but it's a really fascinating project that you can all afford to participate in for just a few dollars, and really create an amazing radio time machine. Thomas?
Thank you for that nice introduction, Bernie. I really appreciate that. So, thank you. This is my first hope. It won't be my last hope. I don't think I'm cool enough to be up here, but this is such a fascinating conference. I know I'll be back. Last year, I was invited to speak at the Radio Preservation Task Force meeting in Washington, D.C. at the Library of Congress. And it was a really big honor for me because it gave me an opportunity to talk about something that's near and dear to my heart, which is the preservation of radio spectrum. And here I am with my fellow panelists and the moderator there. That was like my 5th or 6th selfie I've ever taken in my life. There's no Instagramming here, as you can tell. But I was really proud of that moment. And in that group of archivists, this is a who's who of archivists in the world, academics and people working for the Library of Congress, National Archives, the Smithsonian. It was an intimidating crowd. But I asked them, how many people know what a radio spectrum recording is? And out of probably 150 people in the room, only one raised their hand, and it was David Gorin, who did the pirate radio presentation yesterday, and he's also on our team for archiving spectrum, so it didn't really count. And to demonstrate what a radio spectrum recording is, I'm actually going to do this for you as well. I would ask you to raise your hands, but I can't see anyone up here. I just see a bunch of lights. So what you're looking at, if you're not familiar with a software-defined radio, this is actually a radio right here. It's just a software interface to a piece of hardware, a radio. At the top, you see a waterfall display. Right below that, you see a spectrum display. The spectrum display shows live signals, and what you're looking at is the entire AM broadcast band, right? Like on the AM radio on your car radio or whatever. Each one of those peaks is a signal. And right above it in the waterfall display, that shows you how those signals change over time. So the brighter colors mean it's stronger signals, and you can see this when I start the recording. Below it, there's some audio information, there's a frequency display, and a few other controls that are really common on software-defined radio applications. I'll go ahead and play this. Now, I will note this is basically an off-air recording, so it's not super hi-fi or anything like that. And I also narrate this recording, so you'll hear me talk over it. I'm going to go ahead and start it. So what you're listening to is actually the AM broadcast band recorded in Providence, Rhode Island, May 1st, 1986, starting around 7:59 UTC, which is roughly around 4 o'clock AM. So the news is about to start at the top of the hour.
NBC News, I'm Kevin Gordon. President Reagan himself says, even with the vast resources available to the United States, there is no way of knowing just how bad the Chernobyl nuclear plant disaster really is. Now, the the accident is the talk of the Western world, there are still vast portions of the Soviet Union that have no idea that anything is wrong. Stuart Newbarth with Stanford University says the only people in the Soviet Union who were told about Chernobyl are Moscow and Kiev.
We've been monitoring these broadcasts since Tuesday, and there's been absolutely no mention of anything connected to a nuclear accident. The Siberian people don't know anything about this.
The fire is said to still be burning out of control, and with the fire having spread to the second reactor at the plant. There are some reports...
So it's not just one recording that we have here, not just of this one broadcaster, but everything that was on the AM broadcast band that day. So I'll just tune through it, like as if I were tuning live radio.
Launch from the Kennedy Space Center this evening. It's the first launch there since the Challenger space shuttle explosion. One Challenger investigator says examination of wreckage proves a rocket joint failed, again pointing to a problem with the O-rings. Los Angeles Library officials are not...
We'll speed up the rate at which we take measurements of all types, air, ground, and water.
More in a moment.
P-O-N, P-O-Z.
Try compose.
P-O-N, P-O-Z.
This is the year I'm changing my age. That's right. From now on, it's 38, period.
I think you get the idea. Okay, now here's the interesting thing. This was done in 1986. I didn't do it. So it was made by a radio DXer. These are people who they were not. Their goal here was not to record an important news day or anything like this. This was just a normal day for them. They were looking for distant stations. And what they would do was they discovered that if you use a hi-fi VCR and you connect it to the IF of your receiver, you can actually record the analog signal coming in off the antenna. And the hi-fi VCR had enough bandwidth that you could record the bulk of the AM broadcast band all at once. They would then take that tape, rewind it, play it back through the antenna port of their receiver, and tune through it as if it were live radio. So they could get all the stations they missed at the top of the hour. So this wasn't recorded because of the Challenger incident or Chernobyl or anything like that. It was just a regular day in Rhode Island for Radio DXer. So I know a thing or two about radio. I run a website called the SWLing Post. SWL stands for shortwave listening. And we have about anywhere from 4,000 to 7,000 daily readers. And who knew there were that many shortwave radio listeners in the world? But I'm in the middle of a lot of communications between radio enthusiasts, talking about equipment, talking about things going on in the world. And I also evaluate alpha and beta test and then review a lot of radio equipment. So I spend a lot of time with radio hardware. Also, I'm not new to time travel. I'm an archivist at heart, and in 2012, I created a website called the Shortwave Radio Audio Archive, and it was in response to, I'm very well connected with the radio enthusiast community, and a lot of radio enthusiasts back in the day would make off-air recordings of shortwave radio broadcasts. So they would just literally set a recorder in front of their radio, turn it on, and record what was coming out of the speaker, or had a direct line-in connection or something, and they still do it today. So we have recordings dating from just last month to back to like the 1950s. Hundreds of off-air recordings curated in this library, and it's totally free. I fund this completely out of my pocket. We have no advertisers, no sponsors, no nothing. And it's available as a podcast, so you can subscribe to it and download all these recordings. One really interesting thing that happened a couple years ago is I was contacted by The Wire magazine in the UK, and they were just informing me that they were writing about this website in their magazine because musicians are using it for sound clips. Who knew? So what is radio, right? If you're old enough, you may think of it as tube tabletop radio. If you were a child of the 70s and 80s, you would have the classic Panasonic RF2200 solid-state receiver. I love this radio. Or maybe you think of a Walkman. And more these days, if there are new radios on the market, it tends to be like an FM radio Bluetooth speaker, which is what this radio is right here. I reviewed this a couple months ago. And as they were saying in the previous presentation, where we consume a lot of our over-the-air radio these days is in the car. And so a lot of us, and I'd say probably a lot of millennials, think only of radio as maybe what they hear in the car. But a lot of our smartphones also have FM chips in them. By and large, I think iPhones don't activate them if they have them in the iPhone. Android phones, some companies don't activate the chip. I have always had Android phones that did, and so you just launch an FM radio application, plug in your headphones because it uses your headphones as the antenna, and you can both tune through the FM broadcast band and you can record it as well. And if you happen to have one of those phones that doesn't have the chip activated, I'm sure there's some people resourceful enough to do Google searches and figure out how to fix that. But radio time travel, we need a different type of radio. We need something a little more robust here. We need a software-defined radio. And probably a lot of you know what these are, but I'll refer to them as SDRs in this presentation. And basically, they're a piece of hardware and software together. So they're less like this radio and a little bit more like the one that lives on your phone, where you have a piece of software that is your interface to a piece of radio hardware. And radio enthusiasts, in the radio enthusiast world, I should say, SDRs look something like this. The SDR is a little black box that you see up in the top left corner that usually has an antenna jack, a data port of some sort, and a power source port, or the data and the power and the USB, and you just have two ports, an antenna and USB. And then you have a piece of software, which is down at the bottom right, which is your SDR application, which is your interface to the SDR. I believe very firmly that SDRs have had a tremendous impact on how we view and what we know about the radio spectrum around us. Because instead of being restricted to seeing just a little piece of the radio spectrum at a time and moving a dial through the bands on your radio and hearing just a little tiny thin slice, all of a sudden the entire spectrum comes alive and you can see all of the signals there. This is an SDR application in the 20-meter band, ham radio band, and you can see the spectrum display. So all SDR applications have the same components, which is usually a frequency display, some controls, this live spectrum display, and then a waterfall display. The waterfall display allows you to really kind of visualize everything that's going on in the bandwidth, the swath of frequencies that you've chosen to view and listen to. But back to the time machine part. If you want to build a time machine, you do need a few components. I would bet that most of you have them now. Number one, you need a computer. Number two, an SDR application. And number three, an SDR. The computer, it can be a desktop, it can be a laptop, it can be running Linux, Mac OS, especially Windows. Most SDR applications are actually designed around Windows. It can be an Android tablet running an Android application that's an SDR application. And of course, even little computers like the infamous Raspberry Pi, there are even disk images that you can load up on these that already have all the drivers and everything for software-defined radios ready to go. They have enough horsepower to fully use an SDR. And then number two, you need an SDR application. And the great thing is the bulk of the really good ones are free, totally free. The three I use the most are at the top: HD SDR, SDR Sharp, and SDR Console. You can Google those and find those very easily. Very powerful, very robust. And what I like about them is they can control more than one SDR. They work with several different models of software-defined radios. And also, there are ones for Mac and Linux. This is by no means a comprehensive list. There are a bunch more. I see a lot of development happening in the Linux world right now, which I really like. The Mac world as well, there are some applications available, but again, if you really want to dive into SDRs, there are more options in the Windows market. And again, they all kind of look the same. This is a more complicated looking SDR application. This is SDR Uno, and I'm running it with the new RSP Duo made by SDR Play, which is an SDR that has 2 tuners in it. So you can have 2 completely independent tuners. So the upper half of the screen is the FM broadcast band, and we were just talking about IBOC channels. I've actually highlighted an FM audio channel, and next to it you can see the 2 digital channels adjacent to it that are kind of purple looking in that display, in the waterfall display. And below that, there's a second instance of the application running, and it's on the shortwave radio bands. So it's covering these simultaneously within one window. Number 3, you need an SDR. And there is no better time than now to get an SDR. They are everywhere, and they really span a wide variety of prices. I bet a lot of you already have an RTL SDR dongle. These are very inexpensive SDRs that were originally designed as digital TV tuners that you would plug into your laptop or a PC to receive TV. People very quickly realized that they could hack it and do way, way more things with it. You can turn these into scanners. You can do radio astronomy with them. You can monitor people's tire pressure sensors on their cars if you want to. You can look at wireless doorbells. I mean, just a million different things with this little device. It costs as little as $10. So if you don't have one, just like skip getting a burger tomorrow at lunch and get one of these instead. The software is free. Use SDR Sharp, and you'll be on the air. Now, if you're like me and you're a radio enthusiast, you want something a little more robust than the RTL SDR dongle. And this is one of my favorite SDRs right now, called the SDR Play RSP-1A. SDR Play is a UK-based company. They design and manufacture these in the United Kingdom, and this costs $100, plus about $20 shipping or something. And they receive everywhere, all the way down to 1 kilohertz up to 2 gigahertz. So like really, really wide band, and they have great performance. I wouldn't have known what to do with this when I was a kid. I would have felt like I had command of the world with this particular receiver, and it's $100. SDR Play makes other models. They're a little more advanced, more antenna ports, that sort of thing. They make the new one with 2 receivers. Their top-end SDR, I think, is $269 or so. AirSpy makes they make about 3 different SDRs, and my favorite's the HF Plus. You can't tell from this image, but that has the footprint of a business card. It's very tiny, and it's thick. It's very dense and metal. It has a really nice thick metal case. It has 2 antenna ports on it, and it only really covers the HF bands and a little bit of the VHF bands, but the part of the HF bands it covers, it's just a phenomenal receiver. I mean, incredible performance. And you can pay more. The more you pay for the SDR, the better hardware you get. And if you live in an RF-dense environment like an urban area like New York City, you probably want a little bit better hardware if you're down in the bands that are more prone to noises, like the medium wave and shortwave bands. That was the ELAD FDMS2, which is about $500. This is the Microcom Perseus, which is about a $1,000 SDR that's been around for the better part of a decade now. And just for fun, I threw this one in. This is the Titan SDR Pro. I do kind of continuous evaluation of this radio. It's about $2,400. It was originally designed as it does signal intelligence. So you can set it up to monitor 64 frequencies simultaneously and feed the data coming out of that into decryption programs and that sort of thing. But enthusiasts can buy it too, and you can use it, but you rarely need to listen to 64 channels at once, which is the reason why I believe that most people can get by with an SDR that costs about $200 or less. The RTL SDR dongle can do things that $2,400 SDR can't do. This, I have it set up actually as an ADS-B receiver, receiving the pings off of aircraft as they pass by, and using a little Raspberry Pi. I think that whole setup cost maybe, I don't know, $80 or something. But again, just keep in mind you need a piece of hardware and a piece of software. So the thing about spectrum, when we're talking about radio spectrum, is it's radio in its native format. we're not talking about tuning to a station and listening to the audio. We're talking about a receiver that can receive simultaneously a swath of frequencies. And all the signals that are in that radio landscape, even the noise, everything that's in it. So to me, spectrum recordings equate to radio time travel, as we just took a little journey ourselves here earlier. And just remember, SDRs can make spectrum recordings. You need that piece of hardware to make your own recording. But to listen to them, you can just use an SDR application and someone else's file. So you can do this for free. Just download a free SDR application and then get an SDR file, and you can do your own radio time travel. I do get this question actually quite a lot when I'm talking to people. In fact, most people, if they say, what are you up to these days? And I say, well, I'm working on a spectrum archive. They sort of slowly back away if I start talking to them. And I don't blame them. But to me, the most amazing thing about spectrum recordings is it's very context-rich. I've studied anthropology, and anthropologists are all about context, all that hidden stuff in between the stations that's so amazing. And personally, my favorite part of all of the spectrum is the shortwave radio spectrum. And I don't know how many of you know about shortwave radio. More and more people I talk to these days, they kind of think of it as something their grandpa had. Here's my 30-second explanation. As we were talking earlier, actually, most radio we use these days and most devices we use, like mobile phones and Wi-Fi routers and laptops and things, work off of something called line-of-sight propagation. So the more things you have between the transmitting tower and the receiving antenna, the more attenuation. So if you've ever been with your cell phone in the mountains and you're talking to somebody and it drops out, it's probably because the cell phone signals, the cell phone tower's signal, you're actually in the shadow of maybe a mountain or something like that and you can't hear it. Well, shortwave radio works on an entirely different principle called skywave propagation. Depending on the frequency and the time of day, you can broadcast a signal and it bounces off of the ionosphere and comes back down to Earth in various skip zones. What this means is, and I promise you this, I could go buy a $20 shortwave radio, throw 2 AA batteries in it, you could fly me to the South Pole, and as long as I could keep the radio warm enough to operate, I can receive signals from around the world in one of the most remote parts of the world, because those signals surround us all the time. They're always there. And that's the magic of shortwave radio. And what Bernie was saying earlier, this is the reason why I believe so powerfully in this as a medium of free speech and a media platform, because essentially this is one of our teachers in South Sudan, and she has a hand crank radio. She's in a very remote area. She has no cell phone. If she did, she couldn't pay to charge it. Yet she has a hand-cranked radio, and she can listen to BBC World Service in English, The Voice of America, Radio Japan, and a number of other stations, Deutsche Welle, just a ton of other stations that are still on the air. And shortwave radio has no regard for borders, and if she lived in a country where the people in power decided they didn't want her listening to things outside the country, there's nothing to stop her from doing that, and no one can really trace her, because unless you hear her listening to the radio, you don't know what she's listening to. And many of the stations that I had in that very first recording that I played for you from 1986, many of those AM broadcasters are no longer on the air. And so there are a lot of lost signals out there. And in the shortwave radio spectrum, that's one of my reasons why I'm out there making spectrum recordings in the shortwave broadcast bands. And I wanted to pull up some examples and some little recorded screencasts. This is using my WinRadio Excalibur SDR. And I pulled up, this is from August of 2016. And those of you who don't listen to shortwave wouldn't know that like one of the most awesome stations that used to come on the air every single morning into North America was Radio Australia. And even though they were halfway across the planet, or all the way across the planet, their signal boomed in. And if you look at the spectrum display here, there's like nothing there. And as I was listening for them in this recording, I thought, man, I must have not had the antenna plugged in or something. But I think it was just a day with really bad radio propagation, skywave propagation. So I'm going to play this, and you'll see how Radio Australia used to come on the air even when no one else was there.
Has always given you fairy tales. You know those stories where even if everything goes wrong, at the end of the
There's
day,
just
we
traces
always
of
end
other
up with a
signals
smile on our face and
in the
maybe
waterfall
even a song in our
display, but
heart.
Radio
But
Australia
what
is
happens when
booming
Disney
in.
goes for students or Bluebirds? And Sound and Vision with Lance Sinclair is going to take a look at
They used to be my staple radio station in the morning. I would turn it on while I drink my coffee.
And look at what was really happening in the background of those perfect stories. Do you remember rewatching a film as an adult that you'd watched as a child and realised?
And the audio
how
quality
not
was not that
secure
bad.
in the
It's
first place
as good
that
as
film
a
was?
locally owned
That's about Disney.
broadcaster.
Coming up after the news.
ABC News, I'm Catherine McGann.
Radio Australia went off the air in January of 2017 with like no fanfare at all. They were just cut, and which is happening a lot with shortwave radio stations. They say that this is as a medium for news, that it's kind of a sunsetting technology. So I have hours upon hours upon hours of recordings of Radio Australia on Spectrum recordings, and I can actually go back and hear them as they used to be on the air anytime I want to. So here's another recording of the 25-meter band in the shortwave radio bands. This one has more signals. If you look in the waterfall display, you see way more kind of vertical lines there. And incidentally, the little horizontal lines you see in the Spectrum display, those are actually like static crashes from lightning that's probably 1,000 or 2,000 miles away from my home in North Carolina. So I'm just going to let this kind of run and tune through it. You're going to hear broadcasters, and you'll also hear, like I said, everything in between. You'll hear a digital signal, and you'll hear a spy number station. Everything's there. And the little whine that you hear as I tune around, it's because I was running something called an AM synchronous detector at the same time, and it makes like a little whine as you tune.
Hello, this is Bob Zanotti, formerly of Swiss Radio International, now SwitzerlandandSound.com in Bern, Switzerland. And you're listening to WRMI. Radio Miami interview.wrmi.net. Send us your comments and reception reports to info.
And that station abruptly went off the air, so I widened the filter a little bit. That's called an interval signal. It's a little like a ditty that stations still play at the top of the hour, before the top of the hour, so people know they've tuned into the right station. That's a Cuban number station called HM01, obviously sending a message to an operative in North America. And of course, there's some weak signals in here. That was an RTTY signal I passed over. And that's Radio Havana, Cuba, which is crazy strong in North America today. So that gives you sort of an idea of what's there. Now, as much as I love the broadcast bands with the big government broadcasters and private broadcasters and everything else, like my very favorite part of the shortwave bands in terms of it being a dynamic space has to be where you find pirate radio. And I know that like there would be nobody here involved in pirate radio, of course. As we heard in the previous presentation, that sort of thing's unheard of at Hope. But if one were to know where to find pirate stations, and I wouldn't want to tell you that on shortwave radio, you'd generally find them somewhere between about 6.9 and 7 megahertz. You would find a really dynamic space where people come on the air, they leave the air, you don't know what frequency they're going to be on, and these guys are operating in a part of the spectrum where there really isn't any other thing going on. It's kind of a really quiet part of the spectrum. And if you listen to David Gorin's presentation yesterday, where you can hear anything like about 36 FM pirates in Brooklyn any given night, the pirate radio space on the shortwaves is a lot quieter. a little less stations. But the people are on there because, the barrier of entry to actually have a shortwave radio station in North America is crazy high. It takes a lot of money to do that. So a lot of these guys just build or modify a piece of equipment running maybe anywhere from 5 watts to 100 watts or something, and they put their station on the air. And if you want to hear pirates, listen on holidays. If you want to hear a ton of pirates, listen on Halloween. I promise you. I always record the pirate radio bands on holidays, but especially Halloween. I'm usually out. I'm a kind of a busy father, so we're doing trick-or-treating and stuff, and I don't get to listen to it live. And I didn't get to listen to the Halloween Pirates of 2016. So when I went to make a recording for this presentation, I just pulled up some stuff at random and actually logged a new station. This is one of them. Now keep in mind, these are weak signals, so they don't sound super high fidelity, but I'm receiving this in North Carolina. Probably a lot of these stations are somewhere in the Northeast. And here's one of them.
You're tuned to the fastest station on the 43-meter band. This is Amphetamine Radio, 169.23 upper side band. I do want to give a shout out to Enterprise Radio. Or is that Radio Enterprise? No, Enterprise Radio. Enterprise Radio. Up on 6950. Again, that's
so he's going to shout out to a radio station just a little further up on the spectrum that you can see. But that was the first time I actually ever logged Amphetamine Radio. And here's another one. While I was kind of like having a good time with AHA here, I noticed that another signal came on the air, and if you look on the waterfall display, it'll come up. See that really strong vertical stripe? That is a pirate radio station tuning up. And so I moved my frequency down there to where they are to hear the beginning of their broadcast. That is a pirate radio station interval signal. I mean, it's Halloween, right? I was like, who is this pirate? So one of the cool things about a spectrum recording is you can fast forward and rewind through it. So I fast forwarded until I saw on the waterfall display that there was sort of a quiet part. And when it got really quiet, I thought, well, there'll be an ID in here. And then I heard a heartbeat. So that was Wolverine Radio, and if you listen to shortwave pirates, I'm not saying anybody here does, but Wolverine's out there all the time. And I do record a lot of spectrum. Pirate radio spectrum doesn't take up a lot of space. It's a relatively narrow part of the radio spectrum, but it still takes up some digital storage space, which is actually the fourth thing you're going to need for your time machine if you want to keep any of that stuff that you're tuning to. To put it in perspective, I think I can get about, for 2 gigabytes worth of space, I can get about an hour's worth of that pirate radio spectrum. But the last 3 US elections, I've actually recorded the entire AM broadcast band the day before, the day of, and the day after. 1 day's worth of an AM broadcast band recording like that can easily be a terabyte of data. It's a lot. And some of those elections are a little easier to listen to than others. Some kind of give me PTSD. But anyway, digital storage is a real issue. Nonetheless, even with challenges like storage and bandwidth limitations, I can't just send somebody a file in an email that's a terabyte large, right? There are also multiple file formats with SDRs. They never got together at the beginning when they were making SDR applications and said, hey, let's standardize on a format. They're all based on the same principles, like they tend to use like a WAV file, but the header information and all that is different depending on the SDR application and the SDR being used. Also, file integrity over the long term. If you are storing them, I have about 70 terabytes of data at home on hard drives. Western Digital really likes me. I get frequent flyer miles from them, I think. There aren't a lot of applications that actually run multiple SDRs and can read multiple file formats. Those three I told you about before are some of the best at doing that, and there are a couple in Linux and Mac too, but by and large, SDR applications are kind of limited in that way. And of course, any kind of cost if you want to have an offsite backup, like in the cloud or something, it's one thing to have, I don't know, Google or Dropbox or one of those companies save your emails and things, but it's another thing if you've got 150 terabytes of data. They treat you differently. But even knowing these challenges, we decided to create something, and I put together a team of people who are all dedicated to preserving radio spectrum, and we have a website called the Radio Spectrum Archive. It's at spectrumarchive.org, and you may wonder why we're doing this. Well, as I mentioned earlier, I think it's a really context-rich medium, and I can imagine a day in the future where museums like the Museum in Washington, D.C., which focuses on broadcast history, where you may have a kiosk, and with a simple radio interface, like we were talking about earlier, like the FM dial where you have a tuning knob and you have a volume knob, and you can pull up a recording. Imagine going back and pulling up a recording from, say, December of 1941 and listening to the news as it came through all the major networks when the Japanese were attacking Pearl Harbor. I mean, yeah, that technology didn't exist then, but it exists now, and we're making recordings now. In fact, I would say my AM broadcast band recordings, I make those when there's any significant, like very significant news event, and during elections and other things. And I imagine future media specialists, archivists, historians, and anthropologists going back and probably looking at some of these recordings we're making now of the broadcast bands and trying to figure out why most of the people in the United States, when they consumed media, couldn't do so very critically and know the difference between subjective and objective and real and fake. This is probably a time where we're going to go back and look at that and wonder what was happening. Also, a lot of broadcasters have gone off the air, and we have a lot of these in Spectrum recordings now, me and some of the other people in the archive team. And actually, David Gorin had said once that Spectrum files are a little bit like a fine vintage wine that you can pull from your wine cellar. And you open it up, and there's this, like, the day where something was happening, or maybe the signals were just really coming in really well or something, or there's something important there, and you can listen to it. And that is really what it's like. I can open this wine cellar by just shifting some files to my laptop. When I'm taking a train from Washington, D.C. to New York City, I can listen to these in real time, these time-shifted recordings, as I'm on the train if I want to. But wouldn't it be cool if you could actually share your wine cellar with the world, and everybody else who has their own wine cellar could do that? Well, one of the really cool things that happened after the Radio Preservation Task Force meeting is by way of a really kind person with the Wikimedia Foundation, they introduced us to the Internet Archive team, and who are actually represented here at Hope as well. They enthusiastically agreed to house our Spectrum files, even with the warning of, these are kind of big, are you sure? And so we're in the process now of uploading files and creating our own collection on the archive, which will be really amazing, because all you'll have to do is download a file and download a free application, and you can do your own radio time travel at home. You can listen to recordings people haven't even really listened to yet that they've just recorded and they've put up there for the future, and you can do research if you want to. At the moment, it is kind of limited to downloading a file and downloading an application that coincides with it, but I imagine a day where maybe we could create a web interface, something like the Web SDR at the University of Twente in the Netherlands. They have an online SDR that about probably over 200 people can share at once, and it's kind of amazing. I imagine the same thing. The technology's there to do this as well, and from our talks with the Internet Archive, they'd like to see that happen, but it may take developers, and if there's anyone here who's interested in talking with us about that, I'd love to hear about it, because frankly, we would like to make radio time machines available to anyone who would like to have them. So thank you very much. And I can't see if there's anybody with questions. Okay.
That was a great talk. I really, really enjoyed this one. If I could do a really quick shameless plug, but that leads into a question. So in a half hour, we're going to do a workshop on turning live Bluetooth packet traffic into sounds. So it kind of goes along these lines. Excellent. Which leads into my question, which is, as broadcast now more and more is obviously in an analog medium, but doing digital broadcast. I'm curious in terms of storage, capture, and everything, if you see that as a positive and negative and all the challenges, if you could maybe speak quickly to that if you wanted to capture that.
Okay, in terms of taking, you're talking about taking the difference between archiving digital versus analog?
Exactly.
Okay, yeah. Really, spectrum recordings don't care if something's analog or digital. They just record what's there. So, for example, on the FM broadcast band, if you're recording the entire broadcast band, you would honestly, you could have a number of digital FM stations that are running 2 or 3 HD channels all at once, and it's recording them because it doesn't care if it's analog or digital or anything. So really, digital actually, in a way, you can probably fit more into a piece of spectrum with some digital broadcasts. So yeah, it's always going to be there with spectrum recordings.
Could you envisage, though, decoding the digital signal and recording it as digital and having that as for compression, for instance?
Yeah, you could actually go back into any of our spectrum recordings that have digital signals and decode them at a later time and do what you'd like to with them.
Awesome, thanks.
Yep.
Cool. So I played with SDRs a little bit, and I'm really bad at it. And I'm just wondering, like, you got a lot of really weak signals and signals from all over the world. Like, I have a little $25 SDR thing. Like, could I pick those up with that? Like, do I need, like, a wire antenna, like, to a tree or something like that?
Yeah, that's a really good question, actually. You can use a $25 radio to do that, but if you live in an urban area, you're not going to cut it with the RTL SDR dongle, that $25 dongle, because it's so easily overloaded by stronger local broadcast signals and also noises like lighting and power supplies and things that switch and make noises on the radio. So the best thing you can do with something like that is get a laptop and take it out into a field, a national park or something, and throw a little wire up in a tree, and you'll be able to hear a lot more. Or invest in an SDR, like the $100 or more SDRs that I was showing you. And if you want to do this at home and you live in an urban area, you'd want to look at a magnetic loop antenna. Those amplify the magnetic portion of the electromagnetic spectrum or electromagnetic signal, and it's a lot cleaner. It doesn't have all the noises and things, so you can do that. But absolutely, with the right equipment, and it's really a modest investment, and the right antenna, which you can build yourself, you can definitely pick up signals from around the world.
Hey, how are you?
Hi.
Cool talk. I've used SDRs as like kind of a poor man's spectrum analyzer.
Yeah.
There's a lot of different functions. You were just talking about the loop antennas. My question is, I have a RTL setup. I have the ham it up adapter.
Right.
You know, it's not as sensitive as I thought it would be.
Right.
What single antenna, you know, or what combination of antennas can I use? And I live not in a very urban area, but just to get a little bit more than what I've got now.
Okay, so to answer your question, this again, if you've got the ham it up adapter, I guess, which is an up converter, I'm not sure what kind of filters that has in it, but you have to be careful of overloading that particular receiver, the RTL SDR dongle. It was never designed for HF reception, really. If it can handle it, you could put up, what I use at my house actually is I build it myself with probably $30 of parts, a horizontal delta loop antenna. So I have a horizontal loop that I strung with 3 trees, and it looks like a big triangle. And then I have a piece of ladder line that comes down to a box, which eventually goes into my SDR. Those are really good. They're omnidirectional, and they're really quiet. So if you do have electrical noises around, you can you don't hear as many of them with a horizontal delta loop.
Great. Were there any of the SDRs that you were showing us before that would be better for spectrum analysis?
I would look at the RSP1A. Yeah, they just actually, one of their community members, one of the cool things I like about them, they're great people. They have a really robust community with lots of tutorial videos and lots of documentation. And one of their community members just made a spectrum analyzer application for their SDR. And so I would look at that one. It's $100. You really can't go wrong with it.
Hey, thanks for the talk. Wondered if you could speak a little bit to the difference in I guess, available spectrum that you can look at with each of the SDRs that you showed?
Right, okay, so the wider, actually it's kind of weird, but the more expensive SDRs tend to specialize in a particular portion of the spectrum, and they have filters that inside the SDR that are built for that. So the wider band radios tend to be the cheaper ones, like the ones at $200 and less. That RSP1A I've been talking about goes from 1 kilohertz up to 2 gigahertz. So there are just a number of applications you can do in there. The RTL SDR dongle doesn't go down to 1 kilohertz, but it's pretty low. I think it goes down into the AM broadcast band. It's not a particularly fine performer down there, but it covers all the way up into the gigahertz range. I can't remember what the top end of it is. If you are looking for one and you're wanting to do a wide variety of things with it, look for one that's wide band. You always want to check the frequency coverage first. And just check out the specs on all those. Most of the lower end or like $200 less SDRs tend to be wide band, actually. So they're kind of more versatile in that way. Is there anybody else?
Yeah.
Okay.
Are there any intellectual property concerns with becoming a recorder? Like, does it help you archive?
Oh, for the archive? Well, so, you know, it's kind of funny. The content's kind of embedded in these files, and I spoke with some universities at one point. They're very, very risk averse. They don't want to take on any recordings that could have copywritten material in them. But to even play back one of these, like one of the things we're working out with Internet Archive is our files to the Internet Archive look like a WAV file, like a regular audio file. So when we send it up there, it wants to turn it into an MP3 and all these other formats. But if you play those, you don't hear anything because it is not an audio recording. So you have to have a piece of software to even decode that in the first place. And everything's kind of lo-fi. So I don't think there's going to be any issues with this. There certainly wouldn't be if you're making recordings for yourself. And we're definitely not making any money on this. So it's only costing a lot of money, which isn't a great business plan, but it works for what we're trying to do.
Could you tell us about the state of archiving of the AM band within the United States for important things? It sounds like you do this as a hobby around elections. Is anybody running like a ring buffer so if something really important happens, we can hit it and have the last 4 hours of the AM band in a major area? Is that something you're thinking about, dividing up the country, having an organized system so we've got it all?
Yeah, I think that's a fantastic idea. And I've talked to people before. They're in government departments that say that, you know, the government they've actually been making spectrum recordings, but they just don't keep them. They're not interested in most of them, so they kind of trash them. There are no other efforts I know of. In fact, one of the interesting things from the Radio Preservation Task Force meeting is out of all the broadcasters out there, public broadcasters tend to do the best job of archiving all of their material. AM, or I should say commercial broadcasters, on the other hand, they are more future thinking. They don't think about their past as much. And usually those that have archives of their broadcasts and their radio station history, those are kind of outliers. And usually there's one person championing that. And then when the station gets bought by another station, the next one says, okay, yeah, that room full of like tapes and things, yeah, it's got to go. We need that space. And so they trash it all. There's no one I know of actually doing, as you were saying, like archive recording or spectrum recordings all the time, and then they can just kind of hit a button and make sure they're capturing and saving things as they're happening. But I do see a day when we're doing that. It can certainly be done. There just isn't any software right now that can make that happen. Thank you very much.